Dear students, in this session we are going to see about electric field. So what is electric field? Electric field is the space, the region of space around the charged particle which exert a force on another charged particle brought nearer to it. That means this is a show charge, this is a test charge. When the test charge is bring from infinity or some other point to nearer to this source charge point, this source charge will exert a force on this test charge only at that particular point. That means when the test charge enters the space, enters the particular region around this source charge. So we will say that at this point, this test charge Q naught experience or experience some force due to this source charge. So we can define that electric field is the force exerted by the test source charge on the test charge. So E is equal to F by Q naught. F is a electrostatic force of repulsion or the Coulomb force. So you substitute this force. What is the force value? The Coulomb force formula K into Q naught by R square. That means the 2 point charges Q naught, product of the two charges, and inversely proportional to the distance between these two is R. You put R squared. So E is equal to F by Q naught. So F by Q naught. Q naught get cancelled. Finally we get the expression for the electric field as E is equal to KQ by R squared. Since electric field is also a vector quantity, so in order to convert this scalar quantity, because already I told that the charge is a scalar quantity and the distance is a scalar quantity, so we have to convert the scalar quantity into the vector quantity, because the left side electric field is evidently vector quantity. So like the Coulomb force, here also we have to multiply with the unit vector r cap. So this is a vector form of the electric field. 1 by 4 pi epsilon naught, instead of k you substitute 1 by 4 pi epsilon naught q by r squared r cap, or generally the electric field expression is E is equal to kq by r squared. So now we see that some system of particles. So since we are so far we are seeing only the two charges or one charges like this. If there is a n number of charges present, how we can calculate the Coulomb force? So let us assume the charges q1, q2, q3, q4 are the n number of the charges, qn number of charges are present in this space. So now we are going to calculate the Coulomb force experienced by q1 charge due to other charges present in this space. That is, what is the force exerted by the q2, q3, q4 up to the q1 charges on q1 charge. The distance between the q1 and q2 is r12, and for the q3 is r13 and r14 for q4. If it is a number of the charges, for the nth charge you put r1n. What is this qn? Qn means you can put 100 or 1000 or 10,000 number of charges. So for generalizing things, we get that the total force on this space is equal to k into q1 q2 by r1 to the square. That means Coulomb force q1 q2 by r square. R is a distance between q1 and q2. What is the distance between q1 and q2? r12. Then we have to add with this q1 does not experience only a force due to the q2 alone. The q1 charge also experience a force due to q3 also, q4 also, qn also. So we have to add all the forces. Then we get the expression k q1 q3 by r13 square, k q1 q3 by r14 square, or etc. So finally we get the generalized equation F is equal to F1 vector plus F2 vector plus F3 vector. Similarly for the electric field also. So for the electric field, the expression is kq by r square. For electric force, the R represents the distance between two charges. Here R represents the electric field at that point. You see here, there is a charge q1, q2, q3. What is the electric field of this charge q1, q2 and q3 at this point P? So the electric field formula is E is equal to kq1 by r1 square, then kq2 by r2 square, r3 square, then finally we get the expression e1, e2, e3 plus e4. That means when the distance increases, when the charge distance is increases, let us assume that the charge q4 is present here. So the distance comparable with the q1, q2 and q3, q4 is long. So the distance r squared is also increased, or force squared will be there. That means the electric field E is inversely proportional to 1 by r squared. Dear students, when the distance is larger, the electric field force, the electric field is very, very less. As the point, this is a point charge Q. So if the point P is here, the electric field at this point P is EP. So let us assume the another point Q here. The distance between these two is this one. The electric field at this point is EQ. So this is R1, this is R2. Evidently R2 is greater than R1 is greater than R2. Hence EQ, the electric field EQ is greater than EP, because when the distance increases, electric field also very less. Hence we come to the conclusion E is inversely proportional to 1 by r squared. In practical, it is not possible all the charges are in separation. So all the charges are in the continuous manner, that is called as a continuous charge distribution. So it may be in the 1-dimension form, 2-dimension form or 3-dimension form. 1-dimension form is called as a linear charge density, 2-dimension is a surface charge density, and 3-dimension is a volume charge density. So linear charge density means it is in a wire or in the only x-axis or in the 1 dimension. So the amount of charge present per unit length is called as a linear charge density, that will be denoted by a symbol lambda. Lambda is equal to Q by L. Also for the surface charge, the amount of charge present in the given surface, it will be a 2-dimension. So Q by area is a surface charge density sigma. Similarly for the volume charge density, Q by volume of that cube or any space or any object is equal to volume charge density rho. So the continuous charge density means for linear charge density lambda, surface charge density sigma, and volume charge density rho. For correspondingly, we are divided by the 1-dimensional length and 2-dimensional area and 3-dimensional volume. Dear students, in order to understand the electric field more accurately, I will always explain the compare with the fire. So let us assume that you are standing in this point. So at this point, if there is a fire is burning here, the hotness experienced by you at this point is some value. So some hotness we experience. If you move towards this fire, what will you experience? That it will be more hotter than this point. The similar way, when the charge is here, the distance between the charge and the particular point is more, means the electric field will be, that is electric field value will be higher. That means very, very lower, and when it is very closer to that, the electric field value will be higher. Hence EQ is greater than EP.